Thank you so much, Eva, and thanks for trying the German way of Michael Simons. So that's my name. Nice to meet you all. Great to be here. Yeah, I work as a software engineer at Neo4j. Welcome to the lean way of refactoring Neo4j content. First of all, I have to say I'm really excited about this talk right now. I've seen way too many excellent talks today, and I'm unsure if I can uphold to the previous content. Need to see how this works. Okay. First of all, that project that I'm going to talk about, it's kind of my baby, but as the old saying goes, it takes a village to raise a child. In the last year, I've received a couple of contributions from all over the place, actually internal contributions in terms of questions about bug reports, feature requests, and so on and so forth. Thanks to all the people on this slide. Thank you very much. You are appreciated and your input is appreciated. So what is this not about? It's explicitly not about migrating from one Neo4j version to another. It's also not about Neo4j OGM or Spring Data Neo4j, despite the fact that I'm working on both projects. I might, however, speak about all of these things. Then what is this all about? This is about the fact that you basically can't have not a schema in a database. We've heard this before. Designing a schema is hard, and deciding where to put it is also kind of hard. In many relational databases, you have a schema on write. This means you have a very rigid set of tables, of columns and attributes you need to obey on. And this includes data types, certain constraints, and all of that. In Neo4j, you have a schema on read. The very moment you put an application or even any kind of visualization on it, there's always a schema. What can be part of a Neo4j schema? Today, those can be constraints, indexes. You want to have certain things, consistent part. You want to have a set of things to have consistent labels. You want to have consistent relationship types. And in this set of things, you can use constraints and indexes to make sure that you find certain properties. And within these properties, you absolutely want to have a consistent set of data types, for example, especially when you're dealing with object mapping. I mean, in JavaScript or TypeScript or any not TypeScript, in any language that is not lenient on a type system, you will have issues when you have mixed content in the same properties, right? The only constant in your application's lifetime is change. Requirements change all the time. The data itself, it changes. Processes might change. Maybe an ETL tool gone wrong, or just the requirements or the knowledge changes and you need to remodel. We heard this before in the session about farming. Luckily, other people before us already thought about that topic. There's this book from 2006 about refactoring databases. It has all the content that is actually quite valuable in the lifetime of an application that is centered around a database. It's about versioning of migrations. And migrations is everything from changing, in this book, table names, column names, adding new constraints, changing or dropping constraints, in general, improving the design of your database. It's about unblocking continuous delivery in the context of a database. That book is from 2006. It's very focused on relational database and focused on schema on write, but core things still apply today, especially the topic of versioning your migrations or refactorings or change sets, whatever you call them. I left a list of applicable concepts here. As I said, versioning is important. Putting them actually into version control, checksum them to make sure that you don't apply multiple change set, the same change set multiple times, and also make them validatable. Right? For what did we need a database refactoring tool for? I work primarily on Spring Data Neo4j, and in late 2019, we cooperated with the team from JHipster. JHipster is an application generator framework it generates a front end and the back end for you, and we contributed Spring Data Neo4j backend support for it. It requires a small set of inventory data to be available when it starts up, and we evaluated several options to provide this inventory data. First of all, we looked at just adding a Cypher script, but then there was no built-in way to make sure this script is only executed once. So that was that. We looked briefly at Neo4j OGM Auto Index Manager, if we could use that mechanics to do what we want. In SDN6, we didn't have such a thing yet. Actually, Neo4j OGM Auto Index Manager is one thing that made us want to create the stuff I'm going to show you, because it's notoriously hard to keep that thing up to date with the several Neo4j versions out there. There's a bunch of existing Java tooling out there already. There's Liquibase, very much focused back then on relational. There's also Flyway, also only relational, and Liquigraph, which is very focused on graph. Liquigraph is now obsolete. It became an official Liquibase Neo4j plugin. But we had a bunch of issues with it. I'm going to come to that in the next slide. Our requirements for that project, and in general mostly everything we do these days, is being as dependency free as it gets. We want to integrate with a bunch of frameworks like Spring Framework, but also Quarkus and others, and they already have a ton of dependencies in place. If you add more to that, you are very close to dependency hell at some point, at least. Also, we've seen it in the last year. There was Log4Shell, there was Spring4Shell, and last month or the months before that, common text vulnerability. So each and every dependency you drop into that stuff makes it possible to add another hole. And also, we didn't want to add another layer on the pure Neo4j Java driver. I didn't want to wrap that in JDBC, so as little as abstractions as possible. And that was my personal stomach gut feeling, that I didn't want to go with Liquigraph/Liquibase Neo4j because it uses the Neo4j JDBC driver. That's not necessarily a bad thing, but I wanted to keep it as pure as possible. Yeah, as one does, let's create our own thing. In the end, there's some issue that scratches and you want to solve this. And our thing is very much Liquibase inspired. This is me on the left-hand side with Axel Fontaine from Liquibase, from Flyway. And we're having a good time discussing SQL and relational change set. There's the background of that idea and the tooling. So for what do you might need a database refactoring tool for? I was asked to add this slide in just yesterday. As I said, the refactoring I'm going to present you is not about migrating Neo4j versions from one another to the next one, but you can actually use that tool. It comes with a set of pre-built-in refactorings that allows you to merge nodes or change labels and whatnot. And we also allow to refactoring the old Neo4j 4.4 B-tree indexes into the new range indexes. And my colleague Jared built a tool around this tool that automates most of it. You might want to check this out after the slides. So the history and a short feature overview about Neo4j migrations. It started early 2020 to support JHipster contribution. I added JHipster folks as first external contributor last year. We have now optional validations. We use transactional functions everywhere, and we fully support ODB, of course. The most value-gaining collaboration for us was with Andres Almery from JReleaser. We're doing all the releases with JReleaser, and we come to that in a moment as well. for the benefits it brings to us. And it became an official Neo4j Labs project in December 2021. This year, we added full support for the Quarkus framework, including its native mode. We publish on SDK-man. We have preconditions, so we can actually check if your current database content matches some assumptions or even assertions, and skip refactorings or change set based on that, or fail hard because it's too dangerous to continue. This year has been pretty amazing, and we are quite close to replacing OGM Auto Index Manager fully. We built catalogs for indexes and constraints with the potential of more to come. Already mentioned the built-in database refactoring for renaming labels and types, normalizing properties, merging nodes, and all of that without the requirement of APOC inside the database. For our effort in replacing the existing Auto Index Manager, we started work on an annotation processor. It's already available, and that one goes hand in hand with our repeatable migrations. Future outlook might be the work on undo migration, so that you can move a database forward and backwards actually. We have plans on doing this for the catalog items automatically, and for Cypher scripts with manual undo scripts. This thing is distributed in quite a few different ways. The core API and the plugins for Spring Boot and Quarkus are available on Maven Central, such as the Maven plugin. The CLI, and this is really important for us, comes as native binaries for Linux, macOS, Windows, and also for non-supported operating system with a JVM. This CLI is a native binary. To be able to run it, you don't need to have a JVM on your machine, and that's my main selling point here, on your CI/CD. So that means you can use our CLI to set up a pipeline for your application that prepares your target database in the way you need it. And I'm going to show you this in a second. That CLI is distributed on SDK-man for, I think, all the major operating system, and via Homebrew for macOS. And this stuff works excellent because we are using JReleaser for it. So the environment we imagine to run this are at least two environments. You can run this inside applications, but we recommend this only for inventory data and a bit for moving data for tests. That can be really helpful. But the question is if you put a database refactoring tool into your application, how many instances of that application you want to run? Do you have only one instance? Then you're maybe good to go. If you have a bunch of them, like in many microservices scenarios, you really need to make sure that all of them are able to deal with the given schema on read and have the same set of change set available. So that's kind of tricky. And for production use, we really recommend the CI/CD approach and add to your pipeline a step that migrates your database with our tooling. To make this safe to use, the CLI, of course, supports passwords for the database from the environment or from environment files, so that they should never show up in any log files or whatsoever. Of course, we make use of the graph ourselves, and we store a little information graph inside your database. If you're on Neo4j Enterprise Edition, you can separate a schema database from your actual content database, which I think is quite valuable to keep this separated. And that graph is basically a timeline when you started to develop your refactorings or change sets and moving from one to the next one and so forth. And we record all the meta information, who did this, when did they did this, the checksums of the files, of course, and from which host. You don't need to write analytics on this yourself. There is tooling for this built in, and this looks much like this. The features here, they are on par for all types of distribution. Those features are available in the API, in the Maven plugin, in the Spring Boot starter, in the Quarkus starter, and of course in the command line. In this slide, I use the help feature of the command line to display all of this. You can basically get yourself information about current, applied, and pending migrations. You can initialize a local project. That's really helpful if you go for the CI/CD approach right from the start. You can validate your local and pending migrations. You can clean up stuff. And of course, you can apply things. The run command is slightly different from the apply command. The run command is basically a smart Cypher script runner. I forgot this actually to say on the requirements slide of things. Most of this is pure Cypher. So when you know Cypher, when you know how to write Cypher, you can use this tool. It's the same code you would use in Cypher Shell or Neo4j browser to build your migrations or database change set. If you want to use our catalog-based approach, which gives you a version agnostic way of defining constraints and indexes, then you will need to use XML. But it's a very simple scheme, and we're going to see this right now in our demo, in which we refactor all the graphs. If I would you be please so kind and switch to my screen share? Thank you so much. Excellent. So I've seen a lot of stellar live coding today. I'm going to cheat a bit. I've prepared a GitHub repository with all the steps I want to show, and this will be linked on the last slide later after the demo. Right now you're looking at my IntelliJ, and I have a Neo4j database running in the background that contains the movie graph, visible in the lower right of the screen, just a movie. At the top, you see a SDN6 node. That's our current object mapping tool. And this model has a bunch of deficiencies. It has a ID field, which is the title of the movie. That's not bad per se, because it's not using the internal Neo4j, which can be the internal Neo4j ID, which can be problematic at times. It's an assigned value, but one value that's maybe not that good actually, because a title of a movie is not really unique, I guess. But anyway, let's run this application and see what happens. Standard Spring application, nothing too fancy. I can ask for the movies, or for one movie, so that you can actually have an overview. I ask for the metrics with its attributes, and we see the release year and the title, which is the ID in our case. So first of all, let's add a proper surrogate key and check out the second step here. So I added a generated value to the movie, and I'm using a UU ID here. Spring Data Neo4j will automatically fill this value when saving a new movie. But what about the existing movies? Let's find out. I'm going to restart the application quickly and ask again for the matrix. So you see I have a null value for the ID attribute here, which is kind of problematic because I could not modify or ask for that movie by ID. So, and this is one first reason that you need a database refactoring tool. Let's jump to the POM and add the Spring Boot starter integration. And again, I prepared this already, and it will look like this. These are the coordinates under which you find the tooling. Neo4j migrations, the Spring Boot starter. Current version is 1.14. Yes, I can just restart the application again. And while this restarts, this is of course now the environment of an application itself in which I put the tooling to work. Let's see. I expected to show up in the log, but I don't think that the restart mechanism is smart enough. I really need to hit that button. And you will find information about the current available migrations here. So we find that no packages to scan is configured, and it doesn't find anything to build on in the configured default locations. But you get some information about the database I'm running in. So after that, adding the dependency, let's add one first, refactoring or change set. By default, this will go into the resources folder of your application. That means if it's in your application. And a script will always look like this. We are saying we want to do a convention over configuration, and the file names of the scripts that build up your database change set contain basically the fact that these are versioned. They have an incremental number starting with a 10 here, followed by 2 underscores, and then a descriptive name, and the file name extension is of course Cypher. As I said, those scripts contain pure Cypher, nothing more, nothing less. You can basically use everything you can use in Cypher, and it will run in a managed transaction, so that it's assured that it always succeeds. That, however, proved problematic for other people using it. Sasha Peukert from Neo4j Ops Manager will speak about that later. Not going to spoil him, but go to his talk as well. So when I recompile now or restart the application, the tooling will figure out that there's a migration available, and you don't see the warning anymore, but you see the information and the fact that it applied the first migration. So that should mean if I ask for the matrix again, it has a new and shiny ID property. And we can, of course, look into Cypher shell as well. Return the property. See, those haven't been there before. That was your first database refactoring, and basically that's all there is. But that's all there is in terms of concept. Let's add more. Let's see what our catalog approach is. We also support XML formats. Why did we pick up XML? Because we can deal with XML from our chosen language without dependencies. XML is still built in Java and also in the native tooling. And we didn't want to add YAML or JSON as of now. It's just easy to deal with it, and we think it doesn't read too shabby. So that catalog syntax has some simple words like create and then types. And in this case, I want to create a constraint named movie ID unique. It's of type unique, and it targets nodes identified by a label and with a given set of properties. Let's recompile that and have a look at the log. And we see two things here now. The Neo4j migration tooling noted that it already applied the first migration and went straight for the second one, applied the movie constraint. If I would restart it now, we will see that both are applied. Jumping to Cypher shell again, I can have a look here at show constraints, and only the name so that you can read it. We will see the thing we just created. The other stuff you see is our internal constraints that we need to make sure that only one of the migrations runs at a given time. So what did we just do? We were at fifth step. Let's add some more. Let's add an index. While this was a basically ad hoc kind of thing, we can also build this app as a fully catalog. That catalog here in the third refactoring can contain constraints and indexes alike. In this one, I just added one index to make access to the title more performant. This is important because the HTTP request I've used to retrieve the matrix ask the movie repository to find me stuff by the given title, and I want to make this as fast as possible. So the title is this property, and I want to have an index for this. Yeah, let's recompile the whole project again and see what it does now. As expected, added that index. What I've was working on the last days is to make this possible, to add an additional annotations to that. But that's not there yet. Will be there in a couple of weeks. So, wouldn't that be nice to not have to do this? Actually, yes, that would be very nice. And for that purpose, we created an annotation processor that goes not into your default dependencies, but goes into the build plugins of your chosen build tool. Let's see how this looks like. So this is under the following coordinates. It's Neo4j migrations annotation processor using fitting version here. It has a bunch of arguments, and the one I'm giving it here, it should generate the catalog under this name. This name, R040, create SDN constraints, looks different than the refactorings we had before. It starts with an R. That means it is repeatable. I think I need to restart it fully. Yeah, it didn't kick in yet. It's kind of annoying that the annotation processing in IntelliJ works often so. But if I trigger this manually, no, it doesn't show up. It's irritating. Give it a kick here. No, this looks better. So what that annotation processor does, it goes to your movie, finds there is an ID, which is not the internal Neo4j ID, and it creates a catalog for you and adds some meta information when it was created and so on and so forth, and basically does the same thing. So if I rerun this now, we would see it already restarted. The SDN constraints are there already. Let's have a look again. So those come by a generated name. You can interact with that as well. You can adapt it to your needs, but I think the default ones work pretty fine. So why is this important to have this repeatable? Very, very simple. If I figure out that my person here is actually also a model that has deficiencies because it's using the internal Neo4j ID, which isn't recommended anymore. And I want to make this a UEU ID as well. I can do so by just getting the next step. And it will look like this, as in the movie thing. And I kind of don't want to add a multitude of additional catalogs here. I can. All the catalog items will neatly compose. They build up on top of each other, so you can have multiple of them. But it's kind of annoying to decide where to put this, right? So I'm gonna trigger the annotation processor again. Sorry. And we will see that it added one additional constraint. If this restarted already, and I think it has, and it failed, cool. Sweet. So I'm kind of lost here. I think something crashed here. I shouldn't have interfered with the build process of IntelliJ, but that doesn't matter too much. I'm gonna show different things you can do with it. So this would be repeatable if I wouldn't have messed up the build process. One last thing here is that we can also use built-in refactorings. So assuming I added a property to the movie nodes that notes if I watched them or didn't watch them yet. And you maybe know this from your own database schemes. Especially Boolean properties, for example, have a tendency to diverge. Sometimes they are y and n, or yes and no, or true and false, and basically all of that. And this is one of the normalized refactorings we have that you can use to normalize all that stuff. I mentioned moving data for tests. We can go to the movie tests here, in which I'm using Neo4j embedded with a fixture. This is kind of ugly despite the fact that I'm having Java text blocks I tend to store this. To make this better, we can use the callbacks of the migration tooling that can that will run before or after applying a change set. This is called an after migrate callback here, and that basically contains the same script but outside your tests, and so it is reusable across all of your tests. As you see, I've removed the built-in fixture here, and the find by title test should work nevertheless. So this is kind of too small in the logs. Test is green. And again, in the tests, we can see which migrations have been applied. So basically, all of those we created together, including the repeatable one. And after all of them have been applied, the after migrated callback has been called. This is also an example about how the resources are collected and bundled together. So I have about 2 minutes left to show you how we think this stuff should be used. It supports the environmental files you get from Aura, for example, and you can just use the CLI tool, which is called Neo4j Migrations. And I'm using the binary versions here. This is not using a JVM, and I can point it to my Aura installed. So I downloaded the credentials for an Aura free instance right before this talk. And I'm going to use the info command here I have a bit of lag to Aura from where I live. And you see that all of the migrations that are locally available are yet pending, but I can apply them straight from the command line, same way I developed them in this demonstration. And I'm using them straight from the target classes here. You will do this differently if you put this into a dedicated migration project.
I'm sorry to interrupt, but we need to wrap up.
Just apply all of them. And this instance of Aura is now having a properly designed ID scheme. Yes, sorry, back to the slides then. It's basically the last one I have. So there's a ton of stuff more in that project. I'm happy to answer all the questions on GitHub, on the Slack, or on the community side. You find my contact data in the slide, and my email address and the repository I use during this talk is linked as well. Thank you very much.